In this challenge review, we're going to create the spider AI. The first thing that I'm going to do here is we're going to fill in our pseudocode. So here, we're going to have if current position, which is our transform.position, is equal to point A dot position, then that means that we are now going to target B. And from memory and experience of optimizing this, it makes sense to have a variable to store the current target of our destination. So we're going to use a position variable of vector3, and we're going to call this current target. From that, we're going to say if transform.position equals point A.position, then we're going to say current target is now equal to point B.position. Else if transform.position equals point B.position, then simply our current target is going to equal point A.position. From there, we can go ahead and create our transform.move method. So transform.position equals vector3.moveTowards, and that's going to take in our current position, which is our transform.position, our target, which is our current target, and a step or a speed. So we're going to say our speed that is assigned in the inspector multiplied by time.delta time. Let's save this. Let's hop back into Unity. I'm going to clear my pseudocode. Let's run it and test it out. Let's run Unity. And this is the importance of doing iteration testing. It's easier to track bugs when you constantly test your program. Don't wait to have everything developed and then test it, because then you have to backtrack and figure out where things went wrong. So right now, we're walking in between where we're going. It's moving a little quickly for my taste, so I'm actually going to slow it down to 1. And I think that's a lot more scary. So it's a lot scarier. So we're going to keep the speed to 1. The next thing I need to do now is I need to tell it to idle when it gets to the destination. So let's do that. So I'm going to set my speed to 1, and I'm going to tell it to go into idle when it meets its destination. So if transform.position equals point A.position, here is where I'm going to say idle. In order to do that, I need to get a reference to the animator component. So I'm going to say private animator underscore anim. And from here in void start, we're going to say anim equals get component in children, and we want the animator component. Again, how do I know it's get component in children? It's because we're currently on the parent game object of enemy spider, and I need the animator component, which is inside the child object. So we're on enemy spider. I drop it down. Here's my child object. I want this animator component. So now that I have a reference to our animator component, I can simply say if current target equals point B.position, we've reached our target, let's do an idle. So we're going to say anim.setTrigger, and we're going to trigger our idle animation. Let's save this, and we're going to do the exact same thing for once we reach destination B. anim.setTrigger, idle. Let's save this, head back into Unity, let it compile, and let's run our game. As you can see, the spider is going to make it to point B. He's going to do his idle, but he's still transitioning back. And that's because now we need to basically say, hey, if the idle animation is running, then return do nothing. Familiar, right? So let's go ahead and add that part. So now we have our movement code is perfectly fine. And what I want to do here is we're going to clean this up a bit. So play idle when we reach destination, done. And we encountered a new problem, right? Is that we need to stop the movement. So the easiest way to do this is to first isolate the movement into its own method. So we're going to say void movement. And we're going to take all of this code and we're going to put it inside our movement method. From there, we're just going to call the movement code. Now that we've done that, we can then isolate the movement code if our animation is playing. So the logic for me is basically if idle animation is playing, we want to return do nothing. So do nothing. And as we remember the last time is we need to access our animator. Once I've done that, I can actually get the current animator state info in layer 0 because we're not working with layers. And here I can then say is name idle. And this name is going to match the animation name found inside the animator component or view. So if we open up the animator view, you'll see here that the name of the animation is idle, and that's what I'm checking for to see if it's playing. So here, animator.getCurrentAnimatorStateInfo.name is idle, and that needs to be in an if statement. So here we're going to say if, and we're going to put if anim.getCurrentAnimatorStateInfo sub0 dot is name idle. Grab that, remove this little semicolon. Let's put that in the if statement. If this is a true condition, meaning that we are in idle, we're going to say do nothing. Let's save this, and let's head back into Unity. As of right now, you should start realizing that we are doing the exact same thing twice. Imagine if you had 50 enemies and you were implementing this 50 original times. It's kind of redundant and ridiculous. So at the end of this, you're going to see how valuable class inheritance is. Here we are. You can see here we are walking. And if we look on the scene view, here's our spider doing the idle. We're going to walk to our destination. We're going to idle, and we stop, and then we move back. Last but not least, we need to flip the sprite. Let's hop into our code, and let's flip the sprite. So to do that, we're simply just going to get a reference to our sprite. So we need to say private sprite renderer. And then we want to get, we're going to call this spider sprite. And once we have the spider sprite, what do we want to do? We want to assign it in void start. Spider sprite equals get component in children, because we want the sprite. And instead of the animator component, we're going to grab the sprite renderer component. Now that I have access to the sprite renderer component, we can then flip it on the X. So here, if the target position is A, then we need to flip it on the X. And that's going to be false, versus if you're going to the left, flip X is true. So just like before, we want to go ahead and just simply check right here. We just want to check what the current target is. So if current target is point B or point A, let's do point B. If current target is point B dot position, and I do want to check which order I did for the mouse giant just to keep it consistent. And I actually checked point A first. So we'll do A. If current target equals point A, that means that you're coming from point B. That means you're facing left. In that case, that means that the spider sprite.flipX needs to be true because you're coming back from point B. You're running left. And then here we're going to have else, and we can say spider sprite.flipX equals false. The reason why we can have else is because there's only 2 waypoints. Now I may have included, and I believe I did do that here as well. Yep. So you're either going one direction or the other. So let's save this, head back into Unity, and we can test this out. Let's run our game. Let it compile. And let's see, we're in idle. We're going to walk. We're going to perform an idle, and then we flip and walk back. We're going to idle, and then flip and walk back. Alrighty, that wraps up this challenge review. I'll see you in the next video.